Determine the left-sided limit and the right-sided limit, and the two-sided limit as x approaches 3 pi over 2 of cosine of x divided by 1 plus sine of x. Each of these involves the limit as x approaches 3 pi over 2 of the cosine of x divided by 1 plus the sine of x. The first thing to do is try plugging a 3 pi over 2 in for each of the x's. That will give a cosine of 3 pi over 2 divided by 1 plus the sine of 3 pi over 2. The cosine of 3 pi over 2 is a 0. Sine of 3 pi over 2 is a negative 1. And 1 minus 1 is 0, giving the 0 over 0 indeterminate form. We will need to rework this. Neither trig function is squared here, so we do not have a Pythagorean trig identity to use. Neither trig function is of 2x. We do not have a double angle identity to use. But we do have a trig combination, a 1 added or subtracted together with a sine or a cosine. It's happening in the denominator here. The 1 plus sine x is a trig combination. Rewriting the exact limit as is. A trig combination has a trig conjugate. The conjugate of 1 plus sine x is the same two terms, but opposite sign between them, so 1 minus sine x. We will put the trig conjugate over itself, a form of 1, so that when we multiply, we do not change the value, just the look. So I have limit as x approaches 3 pi over 2. In the numerator, those are not trig conjugates, therefore we will not multiply, distribute the cosine of x in. We keep it factored. In the denominator, those are trig conjugates, we will FOIL. First, 1 times 1, 1. Outside, 1 times negative sine x, negative sine x. Inside, positive sine x times 1, positive sine x. Last, positive sine x times negative sine x, negative sine squared x. The outside and inside terms are equal value opposite sign. They will cancel. Leaving in the numerator, still keeping it factored. In the denominator, 1 minus sine squared x. That has a Pythagorean trig identity. The original identity would be sine squared of x plus cosine squared of x equals 1. We can subtract sine squared of x from both sides, giving cosine squared of x equals to 1 minus sine squared of x, which is exactly what we have in the denominator, so that 1 minus sine squared of x can be replaced with cosine squared of x. Giving the limit as x approaches 3 pi over 2 of cosine of x times 1 minus sine of x divided by cosine squared of x. We still have the 0 over 0 indeterminate form here. We haven't changed that just yet, but it's happening due to, as x approaches 3 pi over 2, the cosine of x. Cosine of 3 pi over 2 is a 0. But we have one factored in the numerator, and it can cancel with one of the cosine of x's in the denominator. There's two of them because it's cosine squared. And we should no longer have the 0 over 0 indeterminate form. What's left is 1 minus sine of x divided by cosine of x. We can now try plugging a 3 pi over 2 in for each of the remaining x's. Which will give 1 minus the sine of 3 pi over 2 is a negative 1. The cosine of 3 pi over 2 is a 0. 1 minus a negative 1 is 1 plus 1. And 1 plus 1 is a 2 over 0. That 0 in the denominator is not actually a 0, since x is only approaching 3 pi over 2 here. It does not reach 3 pi over 2. But a limit result of a non-zero number over 0 equals to either positive infinity or negative infinity, where the sign of the infinity often depends on the side the limit approaches from. Therefore, we have to work out each of the one-sided limits separately. We have the left-sided limit indicated by the negative superscript on the 3 pi over 2 of the original cosine of x over 1 plus sine of x. And the right-sided limit indicated by the positive superscript on the 3 pi over 2, again of the original cosine of x divided by 1 plus sine of x. Let's start with the left-sided limit. That is the 0 over 0 indeterminate form, but we do have a trig conjugate that we can put over itself, a form of 1. And we can now multiply. In the numerator, we do not want to distribute, keep it factored. In the denominator, we do want to FOIL the trig conjugates, just like above. And we have the identity available. For the denominator. So it becomes cosine squared of x, and we can cancel the cosine in the numerator with one of the cosines in the denominator, so we no longer have the 0 over 0 indeterminate form. Leaving 1 minus sine of x divided by cosine of x. The denominator, cosine of 3 pi over 2, is a 0, but it's approaching from the left side here. The left side of 3 pi over 2 is less than 3 pi over 2, though near it. Less than 3 pi over 2, though near it on the unit circle, puts it in the third quadrant, and the cosine in the third quadrant is negative. Because it's approaching 3 pi over 2, cosine is approaching to a 0, but it will remain negative the entire time. So cosine of x can be replaced with a negative 0. 3 pi over 2 can then be plugged in for all other x's, giving 1 minus sine of 3 pi over 2 divided by a negative 0, which is 1 minus sine of 3 pi over 2 is a negative 1 over a negative 0, and 1 minus a negative 1 is a 2 over the negative 0. That 2 is positive. Positive over negative is negative. Non-zero over 0 is an infinity, and there is the result of the left-sided limit. The right-sided limit can be worked out in a similar fashion. Multiply by the conjugate over itself, a form of 1. Do not distribute in the numerator, since those are not trig conjugates. FOIL out the denominator, since those are trig conjugates. Leave the numerator alone for now, but the denominator does have a Pythagorean trig identity. It equals to cosine squared x. We can cancel the cosine of x in the numerator with one of those in the denominator to remove the 0 over 0 indeterminate form. Leaving 1 minus sine of x divided by cosine of x. This time we're approaching 3 pi over 2 from the right side. The right side of 3 pi over 2 on the unit circle puts it in the fourth quadrant. The cosine of 3 pi over 2 is 0, but the cosine in the fourth quadrant is positive. So while it's approaching a 0, it's remaining positive the entire time. So we can replace the cosine of x with a positive 0, and then 3 pi over 2 can be plugged in for all other x's, giving 1 minus sine of 3 pi over 2 over a positive 0, which is 1 minus a negative 1 over a positive 0. 1 minus a negative 1 is a positive 2 over the positive 0. Positive over positive is positive. Non-zero over 0 is an infinity. And there is the result of the right-sided limit. The two-sided limit depends on the results of the one-sided limits. They do not match each other here. Therefore, the two-sided limit up here will be does not exist. And there is the results of the three different limits.